Find the vertices, foci, asymptotes, eccentricity, and graph the hyperbola 4y squared minus 16x squared equals 1. Well, right away, you notice that this hyperbola is not in one of its standard forms. Right? I would really like this to look like one of these hyperbolas. It would look like this one, x squared over a squared minus y squared over b squared equals 1, if I had a horizontal transverse axis. And like this, if I had a vertical transverse axis. It certainly looks more like that bottom one, right? And I guess, another good possibility would be if I had a, shifted center, I'd be looking at a hyperbola in its standard form like this, but based on that equation, I don't think that's what's going on. So our first job is to rewrite this equation so that it's in that form, right? In the standard form of a hyperbola with a vertical transverse axis. Well, if this was not a 1, I'd start by dividing both sides by 1 to make it be a 1. I like to think of that as clever hyperbola trick number 1. Since that's already equal to 1, we have to be a little thoughtful here and think about multiplying by 4 as being the same thing as what happens when we divide by 1/4. I like to think about this as clever hyperbola trick number 2, where I think about multiplying and division really being the same thing in the presence of a reciprocal. All right, so here's a squared, and there is b squared. Well, if a squared is 1/4, then a is 1/2. If b squared is 1/16, then b is 1/4. And in the hyperbola, c squared, that distance from the center to either focus, is a squared plus b squared. Well, c squared is a squared plus b squared. So let's see here. I have a 1/4 plus 1/16. So let's see, that's 4 over 16 plus 1 over 16 is 5/16. And c is the square root of 5 over 4. And in a little while, we'll need to know a decimal approximation for that. So I'm going to go on and grab my calculator. And the square root of 5 over 4 will be about 0.6, so about 0.5590. But I think one decimal place will be good enough for my drawing here in a moment. Well, I have to find all of these things, but I always kind of like to start drawing a picture as early as I can. A's a half, and B's a 4th, so I have pretty small values for A and B, so I'm going to count by a quarter on each axis. 1/4, 1/2, 3/4, and 1. That'll make my picture a little easier to interpret than if I just picked a, like that to be 1. All right, I'm going to draw a central rectangle. The 1/4 is under the y, so I need to go up and down 1/2. The 16th is under the x, so I need to go left and right by 1/4. And there's my central rectangle. That's going to let me dash in my asymptotes. And what I love about sketching hyperbolas is after this, it's really easy to get a pretty accurate sketch of a hyperbola by identifying the vertices and just sketching the hyperbola, getting closer and closer to those slant asymptotes. All right, there's my hyperbola. I found the vertices visually, so it's going to be pretty easy to write down their ordered pairs. They're sitting at 0, plus or minus 1/2. The foci are just a little bit further away at about 0.6. To this scale, that's actually kind of hard to show you. They're really close to those vertices. Well, let's see, that puts the foci at 0, plus or minus and exactly root 5 over 4, where that 0.6 came from. The equations of our asymptotes, I need a slope for each line. For that line, I went up 1/2 and over 1/4. So rise over run, up 1/2, over 1/4. A little arithmetic. And I find out that slope has to be 2. And well, we see that in the diagram as well. So let's see, that's going to be y equals 2x. But we know the other asymptote just has the opposite slope since we're going through the origin. So I found the equations of both asymptotes. The eccentricity in a hyperbola follows the same rule as the ellipse, that it is c over a. So here we have root 5 over 4 all over 1/2. So 2 root 5 over 4 reduces to root 5 over 2. Root 5 over 2 is about 1.1180. And so there are our vertices, foci, asymptotes, eccentricity, and the graph of the hyperbola. So that's it for now.